Now, yesterday we looked into VPM, vertical projectile motion. I explained key critical concepts that one must try to apply and use, and possible ways of questions being assessed in an exam. And immediately thereafter, we did one problem. And in this problem, that is when now we tried to apply all the critical concepts that we spoke about. We spoke about important definitions, possible definitions. Immediately thereafter, what is it that can be assessed, how to apply equations of motion, the choice of direction, as well as now the drawing of the graph. So if it's not drawing, it is definitely interpretation. If it's not a definition, it's definitely the magnitude and the direction of the gravitational acceleration. Ladies and gentlemen, let's look into what is it now that we need to be looking for, especially when we are going now to work with momentum and impulse. So I will just say let's go straight into it, and let me maybe take this one, put it just before the actual one of momentum and impulse. So now, ladies and gentlemen, with momentum and impulse, momentum and impulse, obviously the expectation will be there are definitions that one must be able to know. And the basic one here, when you look into definitions, it's basically the very same thing, which is now what is momentum. The second one will be now impulse. The third one will be elastic collision. The fourth one will be inelastic collision. This is now what we need now to be able to define. But lately we add definitions and laws together. Why do we add definitions and laws together? Because you will be expected now to state conservation of linear momentum. Very, very important. And immediately thereafter, you'll be expected maybe to explain what is an isolated system. An isolated system. Ladies and gentlemen, it is true, yes. All this will contribute something like 2 marks each. But it is the 2 marks that we need, because the thinking here with momentum and impulse, it's usually around plus minus 12 marks or so. So we need that 2 marks in order for us to actually achieve at the desired level and the desired percentage. So just ensure that we understand and know all this. Furthermore, ladies and gentlemen, at number 2 is the application of momentum and impulse. These are things that one must look into. A, it's now the use of P is equals to mv. But we are going to incorporate that with now also the change in momentum. So the change in momentum, ladies and gentlemen, will be change in momentum is equals to mv final minus mv initial. This is now the incorporation or the application that are possible in an exam. These are possible ways in which formulas can be assessed and given to us. The third one is now the impulse equation. Now with the impulse equation, ladies and gentlemen, it's just F net multiply by changing t is equals to changing t is equals to changing t is equals to changing t. So what does this say? This says now there's a clear interchange between these two important formulas. Very, very, very important. And the question should be, then what must happen immediately after this application? Ladies and gentlemen, it's going to be now application of conservation of linear momenta. Ladies and gentlemen, let's be on the lookout for possible integration of topics. What do I mean by integration of topics? Ladies and gentlemen, we have a force there, F net, which is associated with Newton's laws. So the chances are it is easy to combine this with Newton's second law of motion. Furthermore, we see that in most cases we'll be working with one object there and there, but we can be able to integrate this with now work, energy and power. So look on the lookout for such a combination. You might be expected that you actually use Newton's second law or Newton's laws in general for you to apply conservation of linear momentum. Or you might be expected, ladies and gentlemen, to do what? To apply the concepts of work, energy and power, of which we did in detail and understand. So because of that, be on the lookout for that integration. The integration will assist in terms of knowing that, but according to this information that I have, I cannot directly go into using the conservation of linear momenta. Lastly, or at E, is use of F net multiply by changing t is equals to changing t on safety measures, on safety measures. Very, very easy. Then the fourth, number F, what we have now is the graphs, ladies and gentlemen. It's the graphs. The first graph is velocity versus time. And the second graph is momentum versus time. And the third graph, ladies and gentlemen, is F net multiplied by F net versus time. Very, very, very important also to interpret these three graphs. What are we expecting? We are expecting either to draw or just maybe interpret. Let's be on the lookout for that also, ladies and gentlemen. But when you check, all these are things that we did when we basically explaining or working with momentum and impulse. There's a nice video I have on all these concepts and building to more complicated problems of momentum and impulse. But what I wanted to emphasize is the integration of topics, especially Newton's second law when work, energy and power. Be on the lookout for that, because at this stage of the year what we are focusing on is basically the integration. But when and how are we losing marks? Ladies and gentlemen, we are losing marks here only because, remember, choose a direction. This is now very, very, very important, ladies and gentlemen. Choose a direction. That is where majority of us are now losing a lot of marks. So the way we do it, after an easy quick recap of this nature, what do? It's very simple. We just now add one basic question that is going to assist us to address everything that is here, ladies and gentlemen. I said for paper 1, questions will always change, but the application and the principles will still be the same. So ladies and gentlemen, with that being said, let's now look into this problem. I will give you now 10 minutes as we did yesterday. Please get your calculators ready. We are going to try and work on this one such that now we are able to exactly understand what is it that the examiners are trying to assess here. Ladies and gentlemen, let's meet in the next 11 minutes. Ladies and gentlemen, we are told the coefficient of friction between the block and the surface is 0,2. So already we are not used to having friction or information of friction inside a question of momentum and impulse. So already this says somehow, ladies and gentlemen, this question must have an integration of now what? Of now Newton's second law, or let's just say Newton's laws. Somehow. Why can one pick that up? Only because we are told now that there's a coefficient of friction between the block and the surface. The biggest mistake is us not understanding the question. You are right to say it is now embedded, which means they are moving together. I agree. moving together. But the moving together part assists us. They are moving together, ladies and gentlemen. The moving part together assists us in now applying what? Applying conservation of conservation of linear momentum, because they are moving together. It is a collision. We agree and understand. But now, why are we given now the coefficient of friction? Because the examiner wants now the integration of linear momentum as well as Newton's laws. That is what we need to be looking for when we are going to approach this trial examination that is coming soon. So hence I said, just get this and note that in this session or in these exams that we are writing now, there will be tricky questions that are not usually asked the same way. But when we look into this, it's basically just momentum. But now they're introducing the element of Newton's laws into this particular question. At 4.1 is frictional force external or internal force? Ladies and gentlemen, it is an external force. It is an external force for 1 mark. At 4.2, it is a definition or stating of the law. State the principle of conservation of linear momentum. The total linear momentum in an isolated system, or of an isolated system, remains constant or is conserved. Yesterday I emphasized on critical weights. If the weight total is not there, isolated is not there, remains constant is not there, it's true or zero, ladies and gentlemen. And this is what I call snag attack. You must snag with these things for us to be able to get now the maximum marks. Now, ladies and gentlemen, there comes 4.3, and at 4.3.1, the examiner says calculate the velocity of the block after the bullet has been embedded in it. So it means the examiner is actually asking us to calculate the velocity at which the block will move. Let me change the pen. At which the block will need here to move into this direction. So that is where the question is. But now, how can one go about this? Let's see. I'm just going to write a random sketch for us to understand. If I want to use the sum of momentum before is equals to the sum of momentum after, I will have m of the bullet, v of the bullet, plus now m of the block, let me use small letter b, of the block, v of the block, and after collision I will have m of the block plus m of the bullet and moving at the combined velocity. Ladies and gentlemen, let's check if this will assist. I will have the mass of the bullet, but I don't have the velocity at which the bullet is moving. I will have the mass of the block, but I am told that now the block is stationary, which will still give me that now 0. But what is the question now? I do not have this velocity also. I have now the mass thereof. Ladies and gentlemen, it says I have already two unknowns in this formula. Two unknown variables. What must happen now? It means it must be a multi-step, ladies and gentlemen. I must combine now the information given of Newton's laws in order for me to find either now the v of the bullet or the v of the bullet and the mass combined. Very important. So it already says this approach will not work. So something needs to be done differently. Hence we are failing to understand that now. What must I do? It is now the integration of the topics. The integration of the topics says we will need to look into what is it that is given. Ladies and gentlemen, allow me now to say Fnet, let's identify all the forces first. I'm going to draw Fn is equals to Fg, and because it is coming to a stop, it means there's now frictional force acting on it. That is now my Fk from Newton's second law. We don't have a force applied, ladies and gentlemen. Remember, it is just a collision between the bullet, which was already moving, and the block. So this object of mine is actually the mass of the bullet plus the mass of the block. So it means I can easily say now, using Fnet is equals to ma, ladies and gentlemen, which force is actually doing work on this object. It is Fk only, which is equals to ma. Then choosing my direction to the left as negative, it will mean I have negative Fk, which is just equals to ma. But now, what is the mass that we have? It is 0,005 plus 3. I am going to try and calculate the acceleration. The question will be, why calculate acceleration? Let's see. We know that Fk is just mu k because we are given the coefficient, which is just now the normal force. And this looks like our normal problem of Newton's second law. So minus 0,2 multiplied by Fn is equals to Fg, which is just equals to 0,05 plus 3 multiplied by 9.8. Then it will give us our answer in Newton. So I'm just going to write it as 0,005 plus 3. This gives us now 0 comma 0 0 5 plus 3 and a, and then when you calculate everything you find a is minus 1.96 meters per second squared. But now, ladies and gentlemen, that is just the acceleration. Why did I need the acceleration? Let's go back to equations of motion. Vf squared is equals to vi squared plus 2a delta x. Why include the concept of delta x? Ladies and gentlemen, we are given the displacement here. We have now our delta x. So it means delta x will allow me to say it is coming to a standstill. V final is 0. V initial is what we are looking for, plus now 2 multiplied by negative 1.96 multiplied by 0.25, and then V initial, ladies and gentlemen, is something like 0.99 meters per second. Mr. Sarami, inputs please. Onasithole, inputs please, in terms of what we have explained on the approach of 431.
Yes, sir. I understand the work now, sir. Thank you, sir.
Oratile,
I understand the work now, sir.
Tapelo, okay, thank you very much. Ladies and gentlemen, be on the lookout for such integration of questions. Thank you very much. So whatever you know and understand of Newton's laws, when it comes to such a situation, please apply that. When there's something of work energy that you know, when it comes to a point of you now saying, I'm in a question of momentum, but I don't seem to be able to apply my equations of momentum and impulse, it means I must go back and apply the equations of motion and also the equations of Newton's second law. Ladies and gentlemen, I have a formula sheet here. And when I look into this formula sheet of mine, you can see that for forces, they are also integrated with equations of momentum. Hence, it makes it easy for us to have now this integration as per the topic or the question that has been given now to us. Ladies and gentlemen, let's go now to 432. 432. The question of momentum and impulse will somehow also ask for the application of the principle of conservation of linear momentum. So what is left is we have our set of equations of motion, our set of Newton's laws. Then the only thing that is left is to say P initial and the sum of P after is equals to each other. Then what must happen, ladies and gentlemen, I've written this before. I have the mass of the bullet, B, velocity of the bullet, plus now plus mass of the bullet or the box or the block, sorry, B, and then after the collision, ladies and gentlemen, they move now together. That is now m of the bullet plus m of the block. We're having now one final v. So the question said initial velocity of the bullet, so it means they are asking for m of 0,005 kg VB. That is what the examiner is asking there. Plus now what? 3, and it was stationary, but after the collision they are moving together, 0,005, and now, sorry, I missed the 3, plus a 3, and the V final is now 0,99. And when you do the mathematics, you'll find that V of the bullet is just equals to 594,96 meters per second. It is a vector. We just say now towards east. And ladies and gentlemen, this is how you approach a question that has now integration of Newton's laws as well as momentum. So remember, this is a basic approach and revision guide. Please follow it. You have a lot of previous question papers from our website. Somehow you will come across a question where you will have to use work energy theorem before actually using the conservation of linear momentum. Onasithole, reflections please.
Thank you, sir. I understand the work more now, sir. Thank you, sir.
Thank you very much. Oratile.
Sir, understand the work, sir. But I have a question, sir. Thereby if n, so there's the mass that you multiplied, but what's in the second bracket?
It's the 9.8. Remember, it's Fn is equals to Fg, which is just mg. But this mass, remember, it's now the mass of the bullet plus the mass of the block, multiply now by the 9.8.
Thank you, sir.
Thank you very much. Ladies and gentlemen, Mr. Sarame, reflections please.
Yes, I understand the work better, so I see where I made my mistakes, sir.
Thank you very much. But you understand now the integration of topics that we must expect on Friday.
Yes, sir.
Thank you very much. Ladies and gentlemen, from me to you, thank you very much. Let's meet again tomorrow, same time. We will try to do a little bit of few things. Like I said, I don't want to bombard you with a lot of things because my approach and strategies will not change. Now at this stage, I'm just emphasizing critical things that you must just be on the lookout for. With that being said, from me to you, have a lovely evening.